This is question 44 of civil engineering paper of GATE 2017 afternoon session. Consider a square shaped area A, B, C, D on the ground with its center at M as shown in the figure. 4 concentrated vertical loads of P is equal to 5000 kilonewton are applied on this area, one at each corner. The vertical stress increment due to these loads according to the Bossiness equation at a point 5 meter right below M is. So, in this question a square shaped area A, B, C, D on the ground is given with its center at M as it can be seen in this figure. 4 concentrated load of each magnitude of 5000 kilonewton are applied at each corner, that is at point A, B, C and D. So, due to this loading we need to calculate the vertical stress increment right below point M at 5 meter depth as per Bossiness equation. So, this question is from the topic of Bossiness theory of vertical stress distribution in soil. You may study about this theory for different loading condition in detail in lecture 21 vertical stress distribution soil mechanics geotechnical engineering 1 by Professor Dilip Kumar Baid, IIT Kharagpur. So, we know the vertical stress due to concentrated load at any point in the soil is given as by equation sigma z equal to 3q by 2 pi z square into 1 by 1 plus r square by z square to the power 5 by 2. So, in this question 4 loadings are given at point A, B, C, D. So, in this question we will find the vertical stress due to any one of this loading. Since all these 4 points are symmetric with respect to point M. So, first we will find the vertical stress due to any of the loads. Then we will apply the principle of superposition that is we will add all this stress. So, since it is symmetric all these points are symmetric. So, vertical stress will be same due to each loading below the point M at 5 meter depth. So, first we find the vertical stress due to any of the loading. So, the sigma z that is sigma at 5 meter depth due to point load A will be 3q by 2 pi z square. So, 3q is given as 5000 kilonewton divided by 2 pi z, that is z is the depth. So, depth is given in this question 5 meter. So, 5 square into 1 by 1 plus r by r square by z square. So, r is the radial distance. So, radial distance can be calculated here. Since this AD is 4 meters, so suppose this is x and this is y. So, since AD is 4 meters, so AX will be 2 meter. Similarly, XY is here 4 meters, so XM will be 2 meter. So, AM that is R. So, R will be is equal to 2 square plus 2 square. So, it will be 2 root 2. So, here R comes as 2 root 2. So, R square is 2 root 2 square divided by Z square. Z is 5 meter. So, 5 square to the power 5 by 2. So, here after calculation when we calculate this, so we will get this sigma at 5 meter depth due to load at A point will be 47.7 kilonewton per meter square. Since this loading is in kilonewton, so I am writing here kilonewton per meter square. So, now we have the value of vertical stress at 5 meter depth right below point M due to one of the loading. So, for all due to all this loading we can find the sigma 5 due to A plus B plus C plus D will be. So, apply the principle of superposition here. So, since all this loading are symmetric, so we can multiply this loading with 47.7 into 4. So, here we got the value as 190.8 kilonewton per meter square or kilopascal. So here the vertical stress increment due to these loads according to the Boussinesq equation at a 0.5 meter right below M is 190.8 kilopascal. So 190.8 is the correct answer for this question. Thank you.